In this video, we're now going to look at what we call right triangle trig. And before we do that, I want to go back and review what we talked about before with the unit circle. And we talked about our sine, cosine, and tangent, where the sine of an angle would be y over r, where r is the radius, cosine is x over r, tangent is y over x. And then we have the three reciprocals, which would be cosecant, r over y, secant is r over x, cotangent is x over y. So now we want to take this a step further from our unit circle and apply this to a right triangle. And if you think back to where we looked at this before, if this was our angle here, theta, that we're referring to in this example, remember when I started drawing our triangles, I would draw this down and form a right triangle. And I told you this right angle is always off of the x-axis. And we looked at kind of that bow tie example where I said your triangle is always going to be drawing something of this nature. That's what we're going to look at here now. And if we just focus now on the sine function, and everything else is going to be similar throughout, but if we look at the sine function where we say that is y over r, we know that this is our y, this is our r, and then of course if we think of cosine as x over r, we would take this coordinate for your x and divide that by r. Well, now because we're thinking this in terms of a right triangle, we can simply use slightly different terminology, but we're meaning the exact same thing. So if we think of theta as our angle, if we think of opposite of the angle, when I say opposite, we're looking at opposite of this angle, which would be this side here where the y is. So that's the opposite side of our angle. And the x, the side here next to the angle theta, or what we call the adjacent side. And then of course we know this side opposite of the right angle, this is referred to as the hypotenuse. So here we could think of the sine of theta in terms of y over r, or as a right triangle, we could think of that as the opposite over hypotenuse. Okay, so we can think of this either way. So other than that, this is the exact same thing we did before with y over r. We're just calling the y side the opposite of our angle, and the r is representing the hypotenuse of the right triangle. So that means here for the cosine, which is x over r, we could define that as the adjacent side over the hypotenuse. And then y over x for the tangent function, instead of saying y over x, we could say opposite divided by the adjacent side. All right, and then of course the other three are just going to be the reciprocal. So cosecant, instead of opposite over hypotenuse, it would be the hypotenuse divided by the opposite side. And for the secant, it would be the hypotenuse divided by the adjacent side. And for the cotangent, it would be adjacent over opposite. So really we're looking at exactly the same thing we did before. We're just using the right triangle and we're using opposite, adjacent, and hypotenuse to look at our trig functions. Now again, if you don't really care for the right triangle, I mean, you can still think of this in terms of x, y, and r, or if you prefer kind of the right triangle terminology, you can always think of this as opposite side, adjacent, and hypotenuse. All right, so again, if you haven't already memorized with the circle here, the y over r, x over r, y over x, you need to do so. And then also this opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And I will point out here, there is a phrase that a lot of people use here, and there's many different ways you can help to memorize what we're looking at for these different trig functions. And one is, you see a lot, is called SOH CAH TOA. And this is one that I was taught way back when I was in high school, and it still has stuck with me. And what we're looking at here is you're looking at SOH CAH TOA, where S is representing the sine, which is the opposite over hypotenuse. The C is the cosine, which is adjacent over hypotenuse. And for the TOA, this is the tangent, which is opposite over adjacent. So this is kind of a neat little phrase that you can use, SOH CAH TOA, to help you memorize your trig functions. So if you remember sine, cosine, tangent, the other three are simply the reciprocal. So now I want to look at a couple examples of how we might use this to evaluate some trig functions. So let's, for example, say that we are given a right triangle. So if you notice now, we just have a right triangle, and we're not really thinking of the unit circle, but we can still visualize this as inside of the unit circle if we like. And let's say that we have, let's say this side is 3 and this side is 4. So if we're given this particular triangle and we want to find the sine, the cosine, and the tangent of this angle. Now notice we label the angle, and the angle's labeled down here, and most of the time that's where we're going to have the angle located. Now be careful, we could actually put the angle up here, and we'll talk a little bit more about that later, but because if this was the angle up here in blue, the opposite side would be the 3, the adjacent side would be the 4. But the way this triangle is drawn with our angle down here in the left, the opposite side is the 4, and the adjacent side to this angle would be the 3. Now, before we start trying to find our sine, cosine, and tangent, we realize that we're missing the hypotenuse. So first of all, we need to find the hypotenuse. In order to do that, we're going to have to use our Pythagorean theorem. Again, you can think a squared plus b squared equals c squared, or what we've been using is x squared plus y squared equals r squared. So either way, we're going to end up with 3 squared plus 4 squared equals r squared. So we would have 9 plus 16, which is r equals to r squared. And then of course 9 plus 16 is going to be 25. And at this point we want to find r, so we would take the square root of both sides. And again, that means we would have to put in plus or minus. And for right now, we know that we're talking about this r value. It's going to have to be the positive, so that would be a positive 5. And some of you may have recognized this as one of your special triangles where you have a 3, 4, 5 right triangle. So anyway, we have r is equal to 5, which in this case would be the hypotenuse. And I want to label our sides, even though we mentioned it. Theta here, the opposite side would be here the 4. 3 is representing the adjacent, and the 5 is representing the hypotenuse. So therefore, if we want to find what is the sine of this particular angle, and notice we don't even know what the angle is, but if we're looking for the sine, we have our triangle, and we know that the sine function is going to be the opposite over hypotenuse. So the opposite is 4, and the hypotenuse is 5. So therefore, sine of theta is equal to 4 over 5. And then we can continue to find the cosine. And once again, we know that is the adjacent side over the hypotenuse. And that adjacent side is 3, so that would be 3 over the hypotenuse of 5. And then our last trig function here, the tangent, that is the opposite, that's the TOA, opposite over adjacent. So that would be 4 over 3. And of course, then if you wanted to find the others, the cosecant, secant, and cotangent, that would just simply be the reciprocal of these three. Now, once again, if you wanted to, you could think of this as the x, this opposite side would be y, and this would be r. And instead of opposite over hypotenuse, here we would have y over r. This would be x over r. And here we would have y over x. So we can kind of still see this in terms of x, y, and r. Okay, let's try another example. So let's say that we're given the following right triangle. And here we have this side is 5, and the radius or the hypotenuse here is equal to 13. Now again, maybe pause the video and see if you can try this on your own to come up with the correct answer. Now, before we begin, we have two sides of the triangle. So once again, we want to find the third side because we know eventually we're going to need that. So again, we can use the Pythagorean theorem, which is x squared plus y squared equals r squared. Now here it doesn't matter too much. You need to be careful as far as what the r is. That's got to be the 13. So here we would have x squared plus 5 squared equals the radius or the hypotenuse, which is 13 squared. So we would have x squared equals 5 squared, whoops, I'm sorry, x squared plus 5 squared, which is 25, and 13 squared is equal to 169. All right, then that means we'd have x squared equals 169 minus 25, and that's going to be equal to 144. And once again, we need to find the actual value of x. So we take the square root, and we would get x equals the square root of 144, which is 12. So we know this is going to be equal to 12. And once again, once we have the triangle solved for all three sides, we could certainly then go and find the other trig functions, such as the sine of the angle, and sine would be, that's the SOH, so that's opposite. And again, this may help you to label. We would have opposite, adjacent, and hypotenuse. So that would be opposite, which is 5 over the hypotenuse, which is 13. And then for the cosine, that's the SOH, that's AH, so that's adjacent over hypotenuse, which would be the 12 over 13. And then, of course, the tangent, which is the TOA. Tangent would be opposite over adjacent, so that's 5 over 12. And then, of course, you could find the other three by taking their reciprocal. And next, we want to try another example, but in this case, I'm not going to give you the right triangle. What if I happen to give you the cosine of your angle theta is equal to 5 over 6? And of course, here we're looking at your triangle as far as being a right triangle, and we know that we have an acute angle. And for right now, that's what we're going to assume. Later on, we'll look at some other things where maybe we're not necessarily given an acute angle, which means the angle is less than 90 degrees. So later on, we'll look at where we may be talking about any angle, but right now, the triangles that we're going to look at, we're going to assume that the angle we're talking about here is an acute angle, so therefore it's going to be here in the first quadrant. Okay, so later on we'll look at what happens if we end up drawing the right triangle over here in either the second, third, or fourth, but right now we're looking at just drawing that triangle in the first quadrant, so that means it would look similar to what I have here. So again, drawing that would look kind of like this in the first quadrant. So knowing that, if we know the cosine of theta, we want to then from this be able to determine what is the sine of theta. And of course, we already know the cosine. That's given to us. That's 5 over 6. But then we want to also be able to find the tangent of theta. And we could certainly find the others as well. But let's see, from this, can we find the sine and the tangent? Well, if we look at the problem, cosine of theta is equal to 5 over 6. And we know that cosine, again, if you think of that SOH CAH TOA, the cosine you can think of two different ways. We could think of it in terms of cosine as our x over r, or what we just talked about with the right triangle, we could think of that as the adjacent side over the hypotenuse. So if we look at our right triangle, down here we would have, this is the adjacent, this is the opposite, and this side is the hypotenuse. So based on this information, if we, and again, we could label this again as this is your x. So if you like x, y, and r, you can do that as well. So here we would have 5 is the adjacent, so that means this side here at the bottom is 5. The hypotenuse then up here is 6. So then we can use our Pythagorean theorem to solve for the opposite side, or the y. So once again, that means we could take 5 squared plus I'll use y squared equals 6 squared. So you're usually going to be able to, given enough information to give two sides of your right triangle, and you're going to have to use the Pythagorean theorem to find the remaining side. So here we would end up with 25 plus y squared is equal to 6 squared, which is 36. And then that means that we would have y squared is equal to 36 minus the 25. So 36 minus 25 would be equal to 11. And once again here we're going to take the square root, and technically that would be plus or minus, but because our triangle is where it's located, we're going to use a positive, and we'll leave it as the square root of 11. So we now have all three sides of our triangle. And again, don't necessarily take the square root of 11, because if you do that, you're going to get a decimal. And in this case, we want to leave it as an exact answer. Now, if this was a perfect square like before, certainly go ahead and take the square root like we did of 144. We can make that a nice whole number as 12. But if it turns out to be a decimal, just leave it as that particular square root. So now that we have all three sides, we can certainly find the sine of theta, because again, the sine of theta is the opposite. So the opposite over hypotenuse. So that would be square root of 11 over 6. And then cosine was given, that's the adjacent over hypotenuse. And then tangent is opposite over adjacent. So the tangent would be the square root of 11 over 5. And then, of course, the other three would simply be the reciprocal of each one of these. All right, so hopefully now you feel fairly comfortable with evaluating your trig functions using this right triangle trig. And again, keep in mind, it's really the same thing that we've been doing all along with the circle. It's just now we're calling the sides opposite, adjacent, and hypotenuse instead of y, x, and r. And again, for right now, in this first few assignments, the triangle that we're looking at is going to be drawn here as an acute angle, which is going to be located here in this particular first quadrant. Later on, we're going to see what happens when we start drawing the triangle over here in the other quadrants, because then you're going to notice what's going to happen eventually. If we think of this as the right triangle here with this as our angle, then our x and y values, our x value over here is actually going to turn out to be a negative value. But for right now, everything that we're looking at is going to be in the first quadrant. So sine of theta, y over r, opposite over hypotenuse, cosine is x over r, adjacent over hypotenuse, tangent, y over x, are simply opposite over adjacent. And then of course cosecant, secant, and cotangent are your three reciprocals.